Participants, am I audible? Just type yes, just will post yes on the chat box. Okay, fine. Okay, Priya, unmute your camera.
Yeah.
Okay, so we'll move on to the session. Let them join. Very good morning. Welcome everyone. Thank you for joining us for today's webinar. My name is Kumaran. I'm heading Computer Science and Engineering Department, Jaya Engineering College. So we are highly privileged to host the Skillfest webinar series season 5. And on behalf of Jaya Group of Institutions, I welcome you all to the webinar on exploring the power of enterprise service bus. Today we are pleased to welcome our speaker, is PRIYADHARSHINI ASOKAN from Coinstar LLC, formerly known as Outerwall Inc. And Coinstar Inc., Washington, US. We extend a warm welcome to you, PRIYADHARSHINI. Today's webinar provides knowledge about the ESB. The enterprise service bus is the middleware tool used to distribute work among connected components of an application. We are going to hear a lot about on ESB from the expert. Before getting into the session, I request all the participants to make note of the following instructions. So at the end of the session, you can find a feedback link. I ask everyone to submit the feedback form so that the e-certificate will be generated. And e-certificate will be reached you within a maximum of 2 days. In the feedback form, just you can type your name in the capital letter and you can provide a valid email ID. And the second, the technology used here is purely rely on the strength of the local bandwidth. So if you have any audio video issues, okay, kindly click reconnect button. It's placed on top of your screen as labeled the reconnect. And don't close the window, don't close the browser. So in case if you are close the browser or close the window, again you have to re-register, then you can get into the webinar room. So there's any the technical glitch in our side, I will back in maximum of 30 seconds. So don't go anywhere, straight into the webinar. And if you have any questions during the presentation, please type them into the chat box and select QA mode so that it's easy for us to identify the question. We will address all your questions at the end. The recorded version of the webinar will be available in YouTube after 12 hours. So you can watch the replay of video of all our webinars through YouTube. So with this note, it's my honor and privilege to introduce Ms. PRIYADHARSHINI ASOKAN. PRIYADHARSHINI is integration developer at Outerwall Inc. She has over 10 years of experience in IT industry. PRIYADHARSHINI graduated from Anna University with a bachelor degree in computer science and engineering, and she has completed her master's in computer science from University of Washington. She worked as a system engineer at Infosys around 3 years, and she moved to Washington. Currently, she is working as an integration developer in platform team with Coinstar Inc. After her graduation at University of Washington, she started her career with Coinstar and Redbox in 2013 as a software developer in middleware team. So with this brief introduction, without wasting our time, we will move on to the session. I'm very glad to welcome Ms. PRIYADHARSHINI to present. Over to you, PRIYADHARSHINI.
Thank you, sir. It's such a pleasure to be here with you all, and I welcome you all to this session. And I hope all of you are staying safe. And so before we get started, I would like to just give a gist about myself. As Kumaran sir said, I graduated my bachelor's in computer science and engineering from Jaya Engineering College in 2008. And then I worked at Infosys Technologies Limited in Chennai as a system engineer for over a couple of years. And then I moved to Bellevue, Washington in 2010 I made up my mind to do my master's. I gave my GRE, TOEFL, and then I graduated my master's in computer science and engineering from University of Washington in 2013. Since then, I've been with Coinstar as an integration developer with the platforms team. And so what do? I basically develop software for the bus, which is the enterprise service bus. We're going to see this in detail. So we work on a DevOps model. So that's pretty much like where we do design. I do design, I develop, I also, test and then do operations, the production support. That's like pretty much everything. So that's how we work in a DevOps model. So yeah, that's the gist about me. And so we'll get and dive deeper to see what ESB provides and how it satisfies with its capabilities, today's IT trends and needs. So I think we'll go over to the slides and we'll get started with the presentation. So we'll get started. So here we have the power of enterprise service bus. I'm sure you're all familiar, and we are going to talk about the software bus here. And so what are we going to cover in today's session? So this is the agenda. So what is ESB? What does this term mean? What does it really imply, and what does this give, and how does it benefit us? What are the benefits? Like, what are the capabilities, and how does the organization or a company really benefit from ESB? So that's going to be the second topic. And the third one is going to be the ESB components. That's what the ESB comprises of. What is this ESB made of? And what are all the components that are actively working in ESB that really benefit us? So we're going to see all the ESB components. And the next topic is going to be business data integration. This is one key component of ESB, or the key feature of ESB. So business data integration is going to be like, how do we integrate data, and what data integration is like? How do we integrate data between applications? Can you integrate data only between applications, or it's also going to be between two business partners? So we're going to see about all this in business data integration. And the next topic is service invocation. Okay, so we know something called data integration. So how do we integrate data? How does this data integration actually happen within the bus? So that's something we are going to see that's accomplished with the help of services. And we're going to see how these services are invoked and how they are created and how they are used in the middleware. So that's about service invocation. And the next topic that we're going to see is the messaging models. So this is the second key feature of ESB. The first one was business data integration. The second one is going to be messaging models. Like, how do we transmit, or like, how do we send messages from one application to another? How does this really work? That's going to be in messaging models. And then the next one that we are going to see, the last one, of course. So that's going to be the lifecycle management. So how do we start, and how does ESB takes the flow? Like, how does it start with design, and then how does it get into the development phase? And what do you really, install? How do you deploy them? And how do you take it to a production server? So that's pretty much what we are going to see in lifecycle management. And that will be our last topic for today's session. So that's the agenda for today's session. And so we'll go over and get started. So here we are. And what is ESB? What does this really imply? So ESB stands for Enterprise Service Bus. This is an architecture, and it's a middleware tool. We call this a middleware tool. It has its own set of rules and principles for integrating applications together. So when I say integrating applications together, what does this really do? What do you really mean by integrating applications? So when I'm able to communicate from one application to another, or when I'm able to transfer data from one application to another, or when I'm able to interact through some communication channel from one application to another, that's called integrating. That's the term integration, right? So ESB has its own set of rules and principles for integrating applications together. And so since it has its own integrating application form, so it's also called an integration platform that combines the different application and it helps with their interaction. It also provides an abstraction layer between the internal and external systems. So between your producer and the consumer services. So you have a sender and you have a receiver. So that's also called as a producer and a consumer. So we'll go over that in detail. And as I said in the agenda, messaging and integration are the backbones of ESB. They are the key features of ESB. So this is just a gist about what ESB is, what this term means. And let's see how this is implemented and what are the features and capabilities and why did ESB evolve. So to the next slide. Yeah, so this is the diagram of ESB. So we have multiple applications talking to the bus here. You see the bus layer here, and you have multiple applications. You have web applications, and they are not same applications. They're all different applications. So you have a web application, you have the ERP, that's the enterprise resource planning, where you have your HR information, where you have softwares for your financial information like SAP. So you have multiple ERP softwares, right? So you have the ERP applications here, and then you have the file transfers. You can even connect to the mobile applications. You can connect with the databases. You have legacy applications. You have custom applications. You can also include third-party applications. So there are multiple applications that talk to the bus, that connect with the bus. And we'll see how these applications transfer data or communicate with other applications through the bus. Okay. So communication between these applications will be way easier when the bus gets involved. So the bus integrates the system by enabling transfer between them. So this session is going to be more of an overview of ESB and its capabilities, and I'm not going to get deeper into any implementation details, just to let you know. So this is the diagram of ESB to just show you how it is really connected. So if you don't have the ESB, what happens? Why do I have to connect to a middleware layer, right? This is a middleware layer. So now I don't want to connect to a middleware layer. I just want to do a point-to-point connection. Why do I have to have an extra layer, right? If I want to transfer data from one application to another, I can just talk to the application directly and transfer data. So why do I need this, right? So let's see why. So this is what I said. It's a point-to-point connection. So in a point-to-point connection, you see that the systems are able to directly communicate and transfer data with one another. For example, the data format can be XML. You can take it as XML. It can be in any format. For example, we take it as an XML format. So this point-to-point connection becomes very complex and overwhelming in transmitting information. So if you see that there are 4 systems that try to connect to each other. So in this case, we need one interface to connect each system. So we are going to end up developing 16 interfaces in total for just, transferring data or connecting between these 4 systems or 4 applications. So the major drawback of this is they are very tightly coupled. So if I want to change or replace one application, if I want to replace this one application with another application, it's going to be very hard, right? Because they're very tightly coupled. And if I'm going to change one application, it will obviously affect all the other applications because they're all connected to each other, right? So it's very expensive to maintain. And this multiple point-to-point connection is getting really hard. So they don't have a separate routing logic. Its separate routing logic is going to be hard-coded into the application, right? And there is no best practices, like ground best practices that can be established, a common best practice that can be established. It has to be specific to every application. and it's very difficult to support asynchronous processing. So it's going, sometimes if there is a network failure, it might generate duplicate messages. There's not going to be any guaranteed delivery between the data. So all this is going to make it really harder, and it gives a lot of pain points when you go with a point-to-point connection. Here, for example, I've just taken 4 systems, but in an organization or a company, you can imagine how many applications you will have. Internal applications, you have external applications, you will have different business partners. Like your company will have partnership with different other companies. So you might have to transfer data from one application to another. That can be an external application also. So with all these applications talking directly to each other, it's going to become really complex, and this is not how we want it to be really implemented, right? So with ESB acting as a single point of entry to connect all the systems, and each system will only need to communicate to ESB. And ESB takes care of the processing, data transfer, routing, security, monitoring, logging of information. So pretty much covers everything that's needed for a data transfer. So the key features of ESB that you would have grasped from this is routing, data transformation, messaging, and security. So this tells you why we need ESB and why not we go with point-to-point connection, right? So that explains the benefits of ESB here. They're very loosely coupled. Like I gave you an example, you want to replace an application. It could be with numerous reasons, like your company may be expanding, or their needs. They come up with more requirements where this application does not satisfy. So they decide to replace with another application. So in that case, if you want to replace it, or if it's a cost cutting and they want to, get rid of an application, they want to bring up an application that's even cheaper. So in that case, if it's loosely coupled, it's going to be very easy. The application that sends the data doesn't care about what it is. It just sends the data to the bus and it forgets about it. So the bus makes sure the data is transferred in the right format and it's transferred to the right application. So if it's loosely coupled, the plugging and unplugging of the applications or the business partners is going to be very easy when you do a data transfer. And this is scalable. You can scale as many applications as you want. Like I showed you in the diagram, like you can have multiple applications, and all these applications can reside anywhere. It can be on the cloud, it can be a mobile application, or it can be even on a database. So it's highly scalable and it's very secure, and data is very reliable, and it's very easy to maintain. And then it has a separate routing logic inside the bus. It's not specific to the application. It has a separate routing logic inside the bus. So these are the key benefits of ESB. So the next one that we are going to see here is the ESB components. What does ESB really comprise of? Yes, it's the integration. We saw how the integration works, and the messaging. We're going to see how and what are the different messaging models that we have. And the next component is caching. So we have a caching implementation inside ESB. I'm not going to tell about, in detail about the implementation, but we can just talk about what cache is. So cache, and I can explain to you what the concept is. So cache is nothing but it's a collection of temporary data. So I can also give you a real-time example. So it is a store where you keep it so that it's required in future, so you can retrieve it rapidly. So an application can fetch data frequently from memory rather than retrieving it from a database. So, or making a network call. So like, for example, if I need to get postal codes, right? If my data needs postal codes, and if I need to query, if I have 1,000 transactions, for each transaction, I cannot make a network call. And if it's a web service call, I'm not going to make a web service call for each transaction and fetch the postal code data, right? So I make one network call, and I get all the data, and I put it in a temporary store. And for each of my transaction, I'm just going to go query that and fetch the postal code for that zone or state or zip, whatever you want. And then you get the data, and then you prepare your data, you process your data, and you send it to the receiver. But this cache also has an expiry. So when the cache is expired, then it's okay. You can just go again, make a web service call or a network call, and then you can fetch the data. So by doing this, I'm not creating, like unnecessary traffic by making unnecessary network calls. This degrades your performance, right? So if you have multiple ESB servers, your cache is shared across each server and increases your application performance with distributed caching. So this is just an overview of what caching is and how it works. So the next component that we are going to see here is the file transfers. So file transfers, how do we do secured reliable data transfer between A to A and B to B? So A to A here refers to application to application. B to B here refers to business to business. It's more like your business partners. And so we'll go over in detail with each one of this component. And then the last one is going to be the adapters. Basically, it helps with connecting different resources. So we'll go over them in detail. How do we connect resources and how the adapters help us in transferring data, and what are the features and capabilities that adapters in the middleware layer provide us. So that's about the components. Then the next one that we're going to see is a high-level architecture. So a high-level architecture with ESB talks about 3 tiers. One is a mediation tier. The second one is an application tier. And the third one is the messaging tier. So in a mediation tier, you have security, you have logging, you have auditing. And so security and logging, like when a sender sends the information, or when an application sends the information or sends a message or sends the data. So from the start of the event till the bus handles it and sends the data to the receiver, every event has to be logged. So that's what we do in logging. That's the mediation tier. The next one is auditing. Like you have logging at different levels, like you have at the service level, you have logging at server level, and how do you monitor the performance of the servers? That's all pretty much covered in auditing. And routing is how do you route data? How do you decide where this data has to go? It has to go to application A, or it has to go to application B, or how it has to go to application C. How do you handle routing? How do you configure that? So that's pretty much it. So all this security, logging, auditing, routing is all in the mediation tier. The second tier is going to be the application tier. The application tier is the transformation. So data which the sender sends is going to be in one format, maybe an XML format, for example. But the data the receiver wants is not in XML format, it needs another format. So then in that case, you need to transform data from one format to another. And then you also do orchestration, and you also have adapters, you have different protocols to connect, and then you have the enrichment. So enrichment here is, so a sender sends a document with just 5 fields, but the receiver wants additional data, which has to be fetched from a database. That's a different application. So you have to get data from 2 different applications. You merge the data, and then you send it to the receiver. That's how the enrichment works. Okay. And then you have the mapping. How do you transform data? You transform data from one format to another. But how do you transfer data or copy the values from one field to another? That is done in mapping. So this is the application layer. The third layer is the messaging tier. The messaging tier is the guaranteed delivery. It makes sure the message reaches the receiver. And the next one is persistence. Persistence is data persistence here. So how do we persist data? So if I have 25,000 transactions running through ESB, right? And so 10,000 transactions made it successfully to the receiver. So there are 15,000 transactions that didn't make it. So there's some failure on the end system, and something happened in between, or, so it's not working, and the 15,000 transactions failed. So we are not going to go back to the sender and ask him to send those 15,000 transactions. So all the data that is sent is going to be persisted, and then it's going to be sent to the receiver. So you can resubmit those 15,000 transactions that failed from your middleware layer through ESB, through the bus. And then this messaging, we have different models, like we are going to see them. One is with queues. How do we do it with queues, and how do we do it with topics? So this is the messaging tier. So this is on the whole a high-level architecture of how ESB works and how the components are separated into the different tiers and how they are handled. The next one is the business data integration. So we talked about integration. We said we need to integrate data. We need to integrate systems. We need to integrate applications by transferring data. But how do we do this? How does data integration happen within the bus? So integration is performed by services. What is a service? What does it do? And what does it contain? Right? So it's nothing different. Service is like a function or a method call, which you're all familiar with, and it receives data, it performs some required operation, and it returns the data. It also makes them, you can also make this service accessible as a web service. So services can perform any integration task. So once you develop a service and you define its inputs and outputs, you can perform any integration task like transportation, through example like HTTP post, and then transformation. One is transportation and the next one is transformation, where you transform data from one format to another, and also auditing like your current event logging, right? So these are the different integration tasks that your service can perform. So how do you create and develop services? So basically you will have your own IDE, like an integrated development environment, where you can, develop, you create packages. You can imagine something like your Java packages. So you create your packages. Inside your package, you create your folders, services, files, documents, map services, web services. So what all is needed for that application to application data transfer, you create everything inside that package, you develop them inside your package, and then once you're done with the development, you deploy your packages. Okay. So that's how services work. And once you deploy your packages, they are ready for data transfer. So the next one is data encoding. So now you have your services ready and you want to transform the data from one format to another. Right? So you can convert it into any specific format, like you have XML, SOAP, flat file, EDI. EDI is Electronic Data Standards Interchange. So ESB follows EDI standards. That's per industry standards. The next one is mapping. This helps with linking data and data transfer. So you want to transfer your data from one variable to another. For example, you imagine an order document, right? You have some order information that's flowing through. That's the message. Your order information is the message, but there's one field which says email, and there's another field on your receiver side which says address. So your data from email has to get into your address. That's when you do mapping. We have a separate slide for this. I'll show you with an example so that it's clear with the diagram, and you know how we do mapping, like how you link variables. And then the next one is content-based routing. So you route the document from one application to another using content-based routing. Like you have parts orders, you have purchase orders, and then you have so you have parts orders information, like you have your company manufacturing a product. So your warehouse gives you like, these are the parts that we need to order, like the part number, the part type, and the number of parts that are needed for manufacturing the product. So all this is going to be in a message. Or if it's stored inside a database, then you're going to pull the information from the database, or it can be in a flat file, it can be in any form. Okay. So you have the parts order information that's pulled, and you also have the purchase order information that's pulled. So you say in a content-based routing, you say when you see a parts order ID info, then you say, hey, route it to application A. So that's the receiver for parts orders information. And when you see purchase order information, details inside the message, you say that this has to be routed. This message has to be routed to application B. So that's called content-based routing, and that's how you do it. Okay, so this is how we do data integration. So now we have our services ready. We have our services developed. We have our services deployed as packages in ESB servers. It can be deployed to test server. You can test it, and then you can move it to your production server. So it's all ready. But how do you invoke these services? So you can send and receive data to the server from any client. You all know the client needs to be authenticated. It should possess appropriate privileges, and it should be allowed on ports. Only then it can come in and invoke a service. So there are different ways you can invoke. One is you can invoke it from a HTTP client, right? And the other one is you can invoke the service by sending email to a specific email account via SMTP. And also you can invoke it through FTP, where you specify the service location via an FTP directory and you pass your XML input through FTP put. Results will be retrieved by FTP get. So that's how you invoke a service. After you invoke it, you manipulate the data. And then the next one is going to be routing data to receiver or destination. So you have two types of routing data here. One is itinerary-based routing, and the other one is content-based routing. Content-based routing is what I just described with an example of parts order and purchase order. So itinerary-based routing, it consists of a list of services to execute, which can contain routing, transformation, and custom service. So you can imagine something like your itinerary, right? You plan for a trip and you have your itinerary. So that's pretty much. So consists of a list of services to execute. It tells you where the routing transformation has to be, or what are the custom services, configuration information. So sometimes your SOAP header message will have all the defined itinerary data like name, version, unique ID, and then your pipeline will evaluate and retrieve the correct itinerary from the database so that it will be executed based on the routing information, and it will consist of all the services that needs to be executed. So these are the different types of routing. How does bus route information? Okay, so the next one we are going to see here is the map functionality. So in a map functionality, we have the set of values. It sets values, like you can hard code and set values to any of the fields here. So in this diagram, if you see, this is the information the sender sends me. There are like 20, for example, you can think of it as like 15 to 20 fields here. And this one is the information the receiver needs, and it needs only 10 fields. It does not need all the 20 fields. So we are not going to send all the 20 fields. We are going to only map and link the fields that are needed, right? So ESB takes care of this. So sender will send, and they developed the information or message according to their business logic, and they don't care what are the fields that are specifically needed by the receiver, right? So they send application detail with all this information, because there could be another application that also subscribes to this message and they will be needing all the 20 fields. So this application needs only 10 fields. So with the help of mapping, we are going to create links here. Just going to be drag and drop. You link data from one variable to another, and you transform the data during copying. So when I map this ID field to this ID field here, the value from this ID field, so this ID has a value of 1, 2, 3, 4. So this value is going to be copied to this ID here. So that's how the data is going to be transformed from one variable to another. So in order to do it, in case if you don't need the variables, then you can also drop them, like you can delete the variables. So in order to do this, do a mapping or do a link between two variables, you need to make sure the data types are compatible. They should be of the same data type. If they are not of the same data type, then this linking is not going to work. You need to convert them, make sure they are of the same data type, and then do the mapping. So this is how data transformation happens inside the bus. So the next component, so now we understand business data integration. How do we handle data integration with services? How do we create services? How did we come up with packages? And what are included in a service? And then, how do we do mapping? So all this is business data integration. Now we're going to see about the messaging models. So in messaging models, we see that we have a point-to-point. We have the two models that we're going to talk here. One is going to be point-to-point, and the other one is going to be one-to-many. So in messaging, in point-to-point, a messaging sender is called the producer, and the receiver, we call it as a consumer. That's the generic term. So in a point-to-point, producer sends a message to the queue. The queue is here. That's the message provider. And the message consumer receives the message from the queue. So in a point-to-point, it consists of producer, consumer, and a message queue. This model allows to send a message to the message consumer. There will be one queue per receiver in a point-to-point model. The data messages are sent to the queue and then processed by the receiver. There is always a one-to-one relation between the sender and the receiver. So that's how it works. So queue is nothing but it's a channel which helps with your asynchronous service to service communication of messages. Messages are stored in the queue until they are processed and deleted, and each message is processed only once by a single consumer, right? So this is a point-to-point model. And the next model that we're going to see is one-to-many. This is also called the publisher subscriber model, or we call it a PubSub model. So message producer sends a message to a topic, and there are multiple consumers that can subscribe to the same topic and receive the message. So that's how this works. They are built with topics and they operate independently, and they do not need to know anything about the subscriber. So inside the bus, we have the messaging services. So all this is already implemented. We don't do anything from a developer perspective. We don't develop any of this. It's all implemented inside the bus. These are all configurable values where you select if you want to use a queue, or if you go and select you want to use a topic. So it's based on your business requirements. You decide what you want to do in your design phase, your design time. You decide whether it's going to be a one-to-one or it's going to be one-to-many based on the requirements. So eBus also provides messaging services, right? They have services, like they're all built-in services. They're all developed, and you have the built-in services where you can just use these services, and you can send messages. Like you have messaging services, like you have send and wait, you have receive, then you have reply, you have wait for reply. So you have all these message services which are already built. We can use them. And so when I say a message, what is this message type going to be like? It's more like you have the header, you have the properties of the message, and then you will have the body content depending on the message type. So this is pretty much what a message type is. And usually we handle this as documents. You create documents, and that's what you call it as a message. So in generic terms, we say it as a message, but it's more like a document. That's how the designer or the developer handles this message. Okay, so we move on to the next topic. That's the exposing and consuming of web services. So the bus has the capability to expose and consume web services. So if you see that middleware layer provides both REST and SOAP services. REST is based on HTTP, and the HTTP methods that define what to do with the resource are like get, put, post, delete. And the resources are like where your client communicate with your server and you manipulate the resources. Like every functionality can be a resource, and you can query them with get, and then you create them, you update them, you can edit them, you can delete them. You can do all these operations with the resources. So the REST data operation can be in XML or in JSON format. So it supports different types of authentication and authorization, like, OAuth, ACL, SSL, certificate based. So these are the different authentication and authorizations that are used by the bus. The next one that we're going to see here is the file transfers. So in file transfer, what do we do is this is also called as managed file transfer. You see here, you have in the diagram, if you have FTP, you have SFTP, you can also have FTPS, it can be a web client. So you transfer file through these different protocols and different applications. So it provides protected internal and external data transfer from B to B or A to A, or even a cloud-based environment. And it is very secure. It uses a secured communication protocol, and it automates your data transfer based on specific policies or partners. When I say automated data transfer, what this really does is, like if your company has a business partner, right? If it's going to be another company. When I say business partner, it's going to be another company. So that's going to be like company B. right? So when I say documents have to go to company B, I say I configure it. I configure an automated job saying that this is the partner name. If this is the document that's going to flow through, or this is a file that has to be transferred to this partner, and make sure it goes to this recipient and at this time. So that's how you set your automated data file transfers. And then it supports multiple protocols, and it has built-in encryption and security. When I say encryption and security, it's more like you can encrypt like PGP encryption or PGP signing, because these are all like highly confidential information. So you can think of your company having bank accounts, right? Your companies will have bank accounts that will be with different banks. So you have bank statements, like how we receive bank statements. The company will also receive bank statements. So they're all highly confidential information. So you make sure so if the bank is going to send those bank statements, it will be all files. They have to be encrypted. And you make sure those statements flow from the bank to your financial ERP software. So for this example, you can take it as SAP. So it has to go from your bank to your SAP. So it goes through the middleware. So middleware makes sure the bank or the file is encrypted. You can also do a PGP encryption. PGP encryption is where you exchange your private key, public key, you encrypt your data, and then the receiver decodes it and then decrypts it, and then they check, they verify it with the keys, and then they use the file data, right? So you can do PGP encryption, and then you can also use PGP signing, where they do a digital signature again with public key, private key encryption. So all these encryption techniques are already built in. We are not going to build anything from scratch here. They're already built. You just have to hook to them, and you have to make sure your file transfer is very secured and it goes to the right recipient. Right. And the next one in a file transfer is setting up events. Like, how do you set up events? Like events, when I say events, it can be two types of events. One, it can be scheduled events. It can also be post-processing events. Like when I say they are scheduled events, like I say, okay, 7 o'clock, this has to run, this job has to run. I schedule the job to run at particular time. So those are going to be scheduled intervals. So I say, okay, go at this time, go pull the files from the bank. The bank has the files ready in their SFTP server. So we make a SFTP connection, pull the files or download the files from the bank, and then you encrypt it, and then you send it to your financial ERP software. So that's how you set up your scheduled events. You can also have something called as post-processing events. So post-processing events are something like where you say, after executing this service or after invoking this service, after I get a success, go ahead and make this file transfer. Those are like post-processing events. So you can set up various events based on your business requirements and how does your application want the file transfer to be handled. So all these capabilities are provided by the bus. And then it allows end users to upload and download a file. You can upload a file, you can download a file. All these are provided by the file transfer feature. The next one that we are going to see is adapters. So adapters here is they connect to resources, different resources. It can be within the organization. It can be even outside. So ESB server can also hold third-party application adapters. When I say third-party application adapters, so if you're using SAP, right? So then it's more like you can connect to the SAP functions or services where SAP is ready to expose a few of the services that are used by the middleware. So you can connect to them using an SAP adapter. You create an SAP adapter. When I say you create an adapter, what is it? You don't have to be confused. It's again nothing but it's going to be a package. Okay, so it's going to be a package with different functions and different services. And when you want to invoke, like when you're going to send data and you want to, like handle data, or you want to validate something when you send data, then you can use these adapters and that are built with your third-party applications, and you can use it for your development. So it transforms data from one specific format to another. For example, you have a JDBC adapter, right? And this service can receive data from ESB server, and it transforms it into a format required by a database, and it also inserts it into the database. So the next one here is it provides notification services. So adapters also provide notification services. That's it. It listens for a document. If we have a listener and we have notification, so it listens for a document on a certain port, and then it knows like once the message is ready, then it notifies the service saying, hey, the message is ready. you can execute your service and transfer this data. So you have all these capabilities within the bus. And then we have the ESB frameworks. So these are the frameworks that are built within ESB, and they can be used for multiple interfaces. Not multiple, can be used for all the interfaces. So when a developer develops, right, when he or she develop a certain interface, then they make sure they use these frameworks, and it's more like you plug and unplug, you hook to it if you need it. That's how you play with these. So you have a document identification and routing framework, where it identifies a document and it says, hey, this is the routing procedure that it follows, and you route it to the recipient. So you just need to configure things within this framework so that it's easy for your development. And then you also have a file transfer. How do you handle file transfer? What are the different events you want to, set up inside a file transfer? And then you have the error handling. So error handling here can be like, you categorize it into two types. You have business errors and you have technical errors, right? So when the bus transmits data and the receiver throws, a data error, then it's going to be a business exception. If it's something related to a network failure, or if it's a web service call that we are not able to authenticate, or if it's an authorization error that we get when we try to send the data, then it's going to be a technical exception. So that's how we categorize them, and we build a framework based on the errors that we get. So this error handling in framework or interface or package can be used when you develop or build any new interface based on your requirement. The next one is going to be transformation. This is data transformation. We already discussed about this, like how you transform data from one format to another. So you will have all the different data formats inside your transformation framework, and they're all already, like custom built. And then you say, okay, if this is the format, these are the other formats that we convert to, and then you can exchange data. Then you have in-memory caching, you have logging and reporting framework, where you log everything, or like server-based logging, service-based logging. And then you have API frameworks, where a third party or another company, where they expose their APIs, you can go, fetch data from that. So this falls under the API framework. So these are the different frameworks that ESB uses. Okay, so the last one that we're going to see here is the lifecycle management. So the lifecycle management, this is the flow from how do we start with the design, and how do we develop services, develop middleware services, develop packages, and then how do you deploy them, right? You develop through the IDE, and then you install and you deploy packages with the help of a deployer. So bus provides a deployer. You use the deployer and you deploy it to your different servers. Like it can be to a test server, or it can be to your production server. It can be anything. And then the last one is manage. How do you manage things? Like you have so many services running. You have different web services, and then you have the map services, and then you have your ESB servers. You have to monitor your servers, and then the health of the servers, right? So you have a central portal, like where your servers, it shows the health status of your ESB systems. You have the active jobs that are listed, and then it shows the currently running jobs, that are currently disabled jobs, and currently jobs that have failed, that are deactivated. So it also shows the active connections. So you have a separate portal where you go and manage all this, and then you can see and make changes and do a successful transfer. So think we are done with it, and that's about it. Yeah, so I hope I've made myself clear.
Thank you, Priyadarshini. We will go ahead and take some time for questions now.
Sure, sir.
Just a reminder, all the participants, please be sure that type your questions into the chat box. It looks like we have few questions. The first one, how ESB differ from SOE?
So it is built on a service-oriented architecture. It is a service-oriented architecture. Yes, it is a service-oriented architecture. Yes.
Okay. Yes, ESP provide load balancing to improve performance.
Yes. We have multiple servers for load balance. That's a great question. Yes, we have multiple servers for load balancing. So if one node fails, then obviously the other two nodes, or how many other nodes that are configured, they will be up and they can take up the load balancer. Yes.
Next is how to select an ESB for any.
Yeah. As for can you repeat that, sir?
Yeah, how to select an ESP for any application. So suppose you want to develop any application, how to choose the ESP
So yeah, so this is a tricky question. There are different companies that offer their ESB software. So you have Microsoft's ESB product, and then you have Software AG, you have TIPCO. So these are different key companies, and you have open source MuleSoft, which provide their ESB. So there are different things. They come up with different capabilities. Yeah, it depends based on the organizational needs. And cost effectiveness, they decide and come up with a bus, whatever they want to pick.
Is there data storage in ESP?
Yes, we do persist data. Yes, we do. But this like 30 days, 10 days, not more than that. Yeah, it depends. Sometimes even a month of data also we try to persist.
I think we have covered almost all the questions asked by the participants.
Okay.
PRIYADHARSHINI, is there anything else you want to cover before the wrap up?
So I would like to just tell students one small information. So if that's okay, it's nothing to do with the bus, but it's just a general thing, where I get more common questions like basically from my juniors, from my relatives, my friends who are in the student community. They ask this question, like what is a career path that we should take? Like what should we really do? It's very confusing. What should we do? So I would really like to give this one piece of advice to all the students. So it can be any discipline, computer science or electronics, or whatever background you are in. I would really recommend you talking to your seniors, your friends, or people who are really working in organizations, and ask them what they do. Like every employee will have their year-end commitments, like what they have to do for that year and what they have to accomplish for that year. So ask them what their commitments are. A developer will have different commitments. An analyst will have different commitments. So try to understand what their commitments are. So that will really help you and give you an idea what people do in your discipline. So after graduating from computer science, they get into different disciplines. There are multiple roles in a company where you can grow and you can take a different career path. Even after joining, you can change your career path. So when you try to understand that, you will have an idea of how you should prepare yourself when you are going over your 4 years of engineering, Yeah. So that'll really help you. And you can also think in the next 2 years what you want to do or what you want to become. So in that way, it will shape you and it will change the path, how you want to prepare yourself. So talk to people, try to understand what their commitments are. So that will really take you places. So that's one small information that I really want to tell the students. Yeah.
Okay. So thank you very much, PRIYADHARSHINI, for spending your valuable time with us in your busy schedule. I know how busy you are. I think she's managing with work, family, having 3 years old daughter, also pursuing a certification course on data science at University of Washington. Hectic schedule. In between, she has accepted our invitation for this webinar. Thank you once again for readily accepted for our invitation. It shows your bonding towards the Jaya Educational Group. And she's a proud alumni of Jaya Engineering College. She has passed out in the year 2008 from CSE. I hope everyone enjoyed the session. I hope there are more lot the job prospects in this particular area. I don't think is there any opportunity for freshers in the integration development?
Yes, sir. Yes, yes. There are a lot of opportunities here. I joined as a fresher and they trained me with this product. So that's how I got
Okay.
into it. So yes, there are a lot of opportunities for freshers. Yeah. Definitely, yes.
Okay.
And it's a very
So,
interesting
on
thing.
behalf of
Really
yeah.
recommend, yeah.
So on behalf Okay. So on behalf of Jaya Group of Institutions and all the participants, once again, thank you, PRIYADHARSHINI. And at this moment, I place my sincere thanks to our college management. My thanks to our chairman, secretary, ma'am, vice chairman, joint secretary, and principal, and all my colleagues who rendered their support for conducting this webinar series. Uh, Great. Thank you, everyone. We appreciate you being here. The next schedule is on Wednesday, 24/6/2020 at 6 p.m. The topic Cisco networking and unified communication by Mr. David Emmanuel. He's a senior UC technical specialist inside Direct UK Limited. He is connecting from Edinburgh, UK. So thank you all for your active participation. Thanks again for joining us today, and we will see you next on day after tomorrow. Thank you, one and all. Thank you, PRIYADHARSHINI.
Thank you, sir. Thank you. Such a pleasure. Thank you.